in the home stretch. Super fun. And you have, I don't say this to all of the people that I talk to, but this is the best presentation going on right now. And you were lucky, actually, because you're going to get to look into the future of what's happening with food. We have how AI will reshape food markets. Here's how this is going to work. Just so you don't know, just so you wonder who is this random person with a Spoon t-shirt. My name is Chris Albrecht. I'm the managing editor for The Spoon, thespoon.tech. Please come and read and share all our articles. We're going to have a couple people talking in sequence, and then we'll bring everybody back on stage for a little fireside chat at the very end. And we are lucky enough to have Chris Satchell. He's the CTO of Zume. Let's enjoy some artificial intelligence talk, shall we? Please welcome Chris to the stage.
Thank you very much, Chris. Hello. Is this working now? It is. Cool. Well, thank you very much for having me. It's interesting. I meet up a lot in the Bay with other CTOs, and you go all over and you go to conferences. And people always say, like, the first thing everybody says to you is always like, who are you with, what do you do? And I say, oh, I'm with Zume, I'm the CTO. And they're always like, that's amazing, I love your video conferencing software. And I'm like, oh, I'm not that Zume. And they're like, oh, that's a shame, they had a really good IPO. I'm like, yes, I know they had a really good IPO, I'm still not that Zume. So then they ask, well, which Zume are you? I'm like, I'm ZUME, or ZUME for everybody who wasn't born in England and isn't Canadian. And they say, well, what is that? I said, well, the best way to start is to talk about what inspires us in the world, what are the problems we're seeing. And it's all around the food supply chain. So we have a broken food system in the world. I think we all know that. So by 2050, we do not have a system that can feed the 10 billion people that are going to be here by 2050. Now, if you're a bit of a nihilist, you might say that's fine, because by 2050, the food supply chain will have screwed up the world so badly, it won't matter. I don't recommend that perspective, because I think there's something we can all do about that. But it is a very broken system. So if you have, let's say, around 30% of the world's calories going to waste pre- and post-consumption, but you have a third of the world's population without enough calories, that is a very odd situation to be in. Food waste is almost $1 trillion problem. It's like 990 billion. You just round it up. It's $1 trillion problem. And that's the impetus for Zume. Because what we believe is that by using technology, by using data and data science, we can help that problem. And that's what inspires our purpose. Our purpose is to engineer the transformation to a sustainable food future. Now, it's a very grandiose, very big thing we want to do. And we can't do it all ourselves, obviously, but we can help, and we can build platforms and solutions to help the food supply chain. So what do we do? Well, what we try to do at the highest level is balance supply and demand throughout the food supply chain. We try to decrease waste throughout that chain. We have technology solutions all along the supply chain, from farm to fork, to help that happen. But one of the primary things we do that's different is the way we use data, the way we use analytics, machine learning, data science, across the whole chain to help optimize and balance that supply and demand. So it's good to talk about an example. Let's make it concrete. One of our businesses is called Zume Forward. And what we do in Zume Forward is we have mobile cloud kitchens. Now, you've all heard of cloud kitchens, right? Dark kitchens, kitchens that do delivery only. Well, we had the inspiration that if you put them on wheels, literally a 26-foot stepper van that is a fully permitted commercial kitchen, and you connect it to a cloud system that's cooperative, you can use data in some incredible ways. We can predict demand from the customers to understand where to put the vehicle. That's vital. So think about this. Last mile delivery is a $35 billion global business, projected to be $350 billion in the next 10 years. But here's a dirty secret. We call it last mile delivery. If we're being accurate, we would call it last 5 mile delivery. Maybe last 7 mile delivery. The point is, trips are too long. You're burning fossil fuels, you're burning people's time, and you're just eating into margin doing it. So what we thought is, well, if you could move food production into the right place and predict where that place was, you could cut down on those trips. Suddenly, last mile really is last mile. Even better, you could use data, analytics, prediction to understand how to optimize the workflow on the vehicle. You could group orders, again, making it even more efficient, and do it without increasing dwell. In fact, you could predict when food was going to be picked up so that you could get minimal dwell time, the time from oven or prep to consumption. We do all of that with data. You could even go as far as to say, well, let's start predicting what you should purchase in inventory 2 weeks in advance to reduce your waste before preparation. There's lots we can do with data to really reduce waste in that scenario and have a fundamentally different experience. The customer gets a different experience, the courier gets a different experience, food production gets a different experience, and it's all predicated on the fact we can use data and prediction to do it. But let's take a step back. So that's a very local municipal solution. How do we think bigger about the supply chain? Well, if you think about it, if we know demand signals, and we combine it with other data, what we could do is build prediction for the start of the supply chain. So predictive farming. It's very tenable to do just-in-time farming. There's many solutions for that, many people doing it. So if you can get a good enough set of data with the right models that you build, you can start predicting what has to be grown. You can also predict where it needs to go in what format to who, which means you can cut supply chain down. So, may or may not know, supply chain is a very long thing for food. Now, you've got farm to table, that's awesome. But you've also got supply chain that goes 12 to 18 months. Now, if we can use prediction, we can cut that down. That means you don't have to grow produce to survive a 12-month supply chain. You can grow produce to taste great and to have the nutrients you want. And the way you get there is by taking data from each part of the supply chain, combining it with other data sources, building models so that you can do a prediction to optimize each part of the supply chain going back. That's what we're doing in Zume. And it goes from everything from those mobile kitchens to sustainable packaging. That's a different talk. We don't need to get into that today. So we have solutions all along it. Now, when we've done that, and as we've done that, we've learned a lot about AI. And candidly, I've had AI teams, machine learning teams in a number of jobs. And I thought, as we're talking about data, it might be fun just to finish up with a few hard-won lessons. So if you are going to apply data and data science to your business, these are some walls we've already run into. The first that's really important is, it's called machine learning. It is not called machine wisdom. So don't expect for a moment that it will replace humans. It will augment humans, and it can help them, but it won't replace the insights and wisdoms that humans bring. So good news there. The second thing is that data is much more important than the models you use. Now, we can all get excited about technology, and we can say, oh, there's generational adversarial networks, there's discriminatory layers, there's all sorts of recurrent neural networks, got all this great tech, and we combine them in interesting ways. None of it matters unless you actually have good, clean data and good volumes of it, and you tag it correctly. Yes, there's lots of algorithms that don't need tagging, but some of the very most interesting ones, the ones that we rely on, do. So you have to have good, clean tag data. So always remember, data more important than models. Similarly, insights are more important than data science. Again, we can all get wrapped up in data science, but if you don't understand what you're asking, and this was a problem with big data, right, 10 years ago. Every company had a big data strategy. That was awesome. They just didn't even know what question to answer, though, but they had a lot of data. That was fantastic. So you need to know what you need to ask. What are you going to optimize in your food system? And what is the one number that you know if it goes up or down, you're getting better? If you can't answer that, you're not going to make good use of data science. Another part is you want a pipeline, not a funnel. The amount of times I've been in companies and it's like, data's important, let's collect tons of it. And you go, now what do we do? They're like, I don't know, but I have a lot of data. So you go, okay, what about generating insights? You generate insights. Nothing happens. You go, well, I don't understand. You're like, you have to actuate. So you need to go from data collection to insights to actuation. You want that to flow as a pipe, because the real key is you collect data, you tag it, you get it ready, you build models, you generate insights, you generate new activity either digitally or physically or operationally in your systems that improves, you remeasure and you do it again. If you can't actuate, if you can't actually make something happen, you're not going to get anywhere. And then the last point I would make is you also want to centralize. And that's a key thing for us. If you think we're centralizing on a macro level across the supply chain, you need to centralize within your companies as well. If your data's in heterogeneous systems, you can't get it together, you will not be able to build the most interesting models. Same for talent. Get your talent together in the same place. If you're hiring data scientists, you know how difficult and expensive those people are. I would suggest do not distribute them out through the company. Get a center of mass next to your data. Get your data in a lake. If you can do those things, you can start putting really interesting models. That's what we're heading for, and that's what we're going to talk about in the panel. So, summing up, there's a ton you can do with data. If you centralize it, you focus on clean data, you can build great models, but humans are going to be central to that. Unless Elon Musk is right. And then in that case, we're going to be bowing down to our AI overlords. But here's the good news. If that is the case, at least we know they're probably less wasteful than we are. So that's going to be awesome. All right, I will hand back to Chris to introduce the next speaker.
Well, and if Musk is right, we're all living in a simulation anyway, so what does it all matter? All right, so we're going to bring up our next speaker, Mr. Erik Andrejko with the Evolv group, which is part of Kraft-Heinz. Please welcome Erik to the stage, please. Come on.
Good afternoon, everyone. I'm going to follow on the last speaker. I'm going to also talk about a human-centered view of AI. And I'm going to start with a scary picture. So we were all just scared by Elon Musk. We're living in a simulation. The machines are going to cause us to bow down. This image of AI is about 50 years old now. This is what I thought AI was when I was a kid, which is HAL, the evil machine that had a mission in mind, and humans were or were not part of that mission. Humans were irrelevant. So if there's one thing I want you to remember is this one equation, which is AI is not AI. And what I mean by that is that artificial intelligence is not the same as augmented intelligence. So I want to talk about augmented intelligence. And to do that, I want to take a little trip back in time. We'll start in France. This here is the Marley machine. I'm curious, does anyone know what this does? This is the most complicated human artifact built in the 17th century. The King of France, Louis XIV, built a palace called Versailles. He decided that it should have a lot of fountains. And what's the point of being the King of France if you cannot run all of your fountains with a lot of water? I know I wouldn't want to do it. So this is an example of necessity is truly being the mother of all invention. To get water up the hill to the Palace of Versailles, he needed a machine. And so this type of mechanized machinery essentially kicked off the Industrial Revolution. And you would naively think at that time, the way that we can mechanize everything we're doing today is to just replace the horse with a better horse. Right? A horse is a general purpose machine. You can do agriculture with it. You can haul water with it. You can bring goods to market with it. So we need one of these, and our problems will be solved. But we didn't get this. We got this instead. So you can imagine an 18th century reporter complaining that he wanted a mechanical horse and all he got was a simple little motor. Like we complain today that we don't have flying cars. Instead of the horse, we built these specialized machines. And coincidentally, this thing still works, by the way. If you go to the museum, I think this is in Denmark, if I remember correctly, this thing still operates. So if you're building any technology today, imagine if it still worked 150 years from now. And these technologies didn't replace the best technology of the time, things like the horse, they simply augmented it. Here's a factory producing steel, and you notice that the horses have more work in this world than they did before, hauling materials to and from the factory. And in fact, the greatest increase in productivity came not from the machine itself, but from the integration of the machine over time into human systems and processes. And an example from the mechanical loom, when the mechanical loom was invented, productivity in cloth weaving did not increase dramatically immediately. It took decades of iteration and integration between machines and humans to see 8 to 12 to 20-fold increases in cloth production. So here's the parallel in AI. So one thing to think about is that just like the rote mechanical tasks of the world were essentially replaced with simple machines like motors in the Industrial Revolution, you should imagine the rote cognitive tasks that we have today being replaced by simple machines that we can think about as forms of AI. And specifically, let's not think about AI as in HAL, this general intelligence that's deciding everything, sensing everything, and acting on all domains, but think about specialized applications of AI. So that, I think, is one big lesson that we can draw from the Industrial Revolution. And even further, if you think about AI as a system which needs to perceive the world, make plans, and carry out those plans and act in the world, you can get by if you remove some of those elements. So it's enough just to be able to perceive the world and make predictions. That's essentially machine learning. You don't even need a fully complex, specialized artificial intelligence to get a lot of value. And as we had talked about just before, it's not really about the algorithm. No one cares much about the algorithm. I mean, I do, but I'm a technologist. But the people using the systems don't care about the algorithm. So the most important thing is the application and what is being augmented. So if we apply this to the food domain, here's a couple of different areas to think about augmentation in the food domain. So one, this is an area where I have personal experience. This is agriculture. Today, food production is largely augmented not only by machinery, but increasingly by intelligence in the form of business and support tools. So for example, a farmer in the US who is growing wheat, say this is wheat in, let's say Nebraska as an example, they'll have on the order of tens of thousands of acres. The amount of fertilizer that needs to be applied, the optimal amount of fertilizer needs to vary on a meter by meter basis. That's a tremendously large number of decisions that need to be made as to how much fertilizer to apply to each parcel of land based on the soil type and weather conditions. And that's an example where the human can be involved in a very strategic level, deciding to grow wheat in Nebraska, and the machine can decide how much fertilizer to apply, when, and where, and together you get a much better outcome than you would with just one alone. This also applies in specialty crops. Here's an example of an automated fruit picking robot. This allows for picking fruits at peak ripeness, depending on the transport to market, as opposed to picking all the fruit at once in a more large-scale production facility. And the example that I'm more increasingly interested in today and working on this is this example of augmented cooking, and where the augmentation is specifically to be able to take a request like this, which could come from a conversation between, say, a family in the morning. Oh, I feel like having butternut squash tonight, and turning that into an automated list of groceries to purchase, which is a rote cognitive task that not many people enjoy, writing down shopping lists and making the dozens of decisions needed to go shopping. And then another machine, here's an example in the world today. This is the Kroger Neuro delivery robot. Again, an augmented system, which has a human who picks the groceries, packs the machine, and then the machine can do an automated delivery route. And then ultimately leading to this very, very human experience, which is eating together in a small group and working together cooperatively with the aid of machines to nurture each other in a family setting. So to me, this is really what it's all about. And this is an essentially human experience, one that I don't think will ever be completely replaced. It's not just cooking at home. There are also lots of experiences one can imagine augmenting the restaurant experience. Again, this is a very human experience of eating with other people. But you can imagine having a machine that knows information about one's diet, one's preferences, one's exercise regime, and provides suggestions and reads the menu perhaps on your behalf, even in an augmented reality situation. So there's one other trick I want to leave you with, which is kind of like the internet is thought of as a series of tubes. AI is just augmentation all the way down. So not only is AI augmentation in terms of application, but one can think about AI as augmentation in terms of the actual development. So this is a bonus trick for those who are technologists in the room. So if you want to build a useful, specialized AI system or machine learning system, one way that you can do this is you can start with a large unstructured data set. So you may not have a lot of labeled data that you would like to have to do machine learning, but you can start with a bunch of large unstructured data. You can then apply some semi-structured, unstructured learning algorithms to learn latent structure. If you look in the background here, you'll see an actual example of that. In this case, this is an AI system that has learned without being told to learn which consumer food brands are like other consumer food brands and which foods are like other foods. So this comes from just having a large unstructured data set of grocery items. And then you can combine these large data set from which you've learned latent representations with a specialized label data set and do augmented learning. So this allows leveraging very large data sets and specialized label data sets for a particular domain. So thank you very much.
All right, so we just talked a lot about data. We've talked a lot about unstructured data. We've talked a lot about all kinds of data. What I want to know is, how long did it take you to figure out the data that was necessary? So, like in the case of Zume, you could go, so for those that don't know Zume, they take hundreds of data points and figure out who's going to order what pizza where, right? So they can go to a neighborhood, set up a mobile kitchen, and get pizza delivered. They know with a pretty high degree of confidence what kinds of pizzas are going to be ordered when and how much. And they do that by taking in things like local sporting events, weather, if school's out, time of year, right? And what I want to know from both of you is, how do you figure out the right data versus all the data? Because to your point, you both have talked about, if you just vomit everything, it's not going to really help you. But how long did it take you to get what you really need to make those predictions without going too far down a rabbit hole, right?
Well, I'd say we're still learning, because there's always more data you can bring in. And often when you're building models, what can happen is you think you have a useful data signal that you've made into a feature, and then you can mathematically see whether it's affecting the model or not. But it's sometimes counterintuitive. Like, we were convinced for a long time, weather must have some impact on people ordering pizza. Turns out it has no impact on people ordering pizza. And the amount of arguments in the exec suite about we've got to get weather information. What we find is, like you said, sporting events, school holidays, our own marketing calendar, massive impacts on that certain type of demand prediction. So in some ways, you have to really just try a lot of different data sets and features and start iterating on them to see what actually is making an impact, because you always have a historical data set that you can both train against and then test against. And you just got to try different features to understand the kind of impact it has and whether it's actually trending towards something. I would say to get some really good models for demand prediction took us really 9 months. If you want just like a time estimate, to constantly iterate on it. And we're still going now, right? We still always find more information. In contrast, as we got better at it, picking new data sets, both our own data and commercially available data, or data available from the government, to predict where to put mobile kitchens in areas we've not run yet. That actually, we've made an awful lot of progress in 3 months. So we started to get a feel of what's likely to make an impact. It's sort of like you were saying with augmentation. Humans have a good amount of insight, and sure, we got weather wrong, but we got a lot of other ones right. And often you can have just some notion of what's likely to impact it and then go test it.
Yeah, Erik, I think it might be good you're with the Evolv group, which is part of Kraft-Heinz, right? And you're as part of a digital hub for them to sort of create tech innovations. How are you, like in terms of data and AI, what is your role inside an organization like a CPG company like Kraft-Heinz?
Yeah, I guess the short answer is, as a data scientist, there's no data like more data. So always having more. I've never had a data scientist tell me they wanted less data.
Okay.
So I joined Kraft-Heinz through an acquisition. So I was co-founder of a company called Wellio, working in this space, and part of the domain that was selected for the company was informed by a data strategy. So I knew from day one that I was going to be interested in working in machine learning in a certain space, and so the data strategy informed actually which space we ended up working in. And I think that's a very important thing to think about, is the data strategy in addition to the types of problems that you're wanting to solve.
Sure. So a day-to-day for you, how are you collecting, applying your data into your AI? Yeah,
so the largest source of data that we actually have that forms a lot of our foundations is actually web crawl data. So food is one domain where people spend a huge amount of time online, photographing it, talking about it, writing recipes, writing other content. So if you look at kind of our foundational data in terms of volume and scale, it's all web crawl data. So from that you can learn basic food facts like Parmesan Reggiano is an Italian cheese. So you can essentially build a baseline knowledge of the domain. Then on top of that, we have a bunch of then proprietary data that comes from internal sources, from third-party vendors, from data that we intentionally collect from subject matter experts like chefs to produce labels. And combining those two things together kind of really gives us the models that we end up using at the very top layer.
What do you think are sort of the limits of predictive AI? Like, you both have talked about it's not going to replace humans, right? So there is a certain amount of intuition, a je ne sais quoi that our meat bags bring to something. But what do you think are people? It seems to be in people's minds it's like a panacea, right? Well, we'll just sprinkle a little AI on it and it'll figure it out, right? But what are some of the limits that people should be aware of before getting into it?
Just one quick one. I've never seen a machine learning system suggest a problem to solve.
Yeah.
The problem has always come from someone else. And so formulating the actual business problem and business need, I think, is never going to be automated.
Okay.
And especially if, when you've got you've got assisted learning, you need to know, versus clustering or anything else, you need to know, to your point, like, what actually represents a better output? Like, if you don't really know what that thing is you're optimizing, and whether like more or less is good, you can't really get anywhere in it. And it's sort of like AI's, I mean, all a lot of machine learning does, right, is it maps one space to another space. It's just a mapping. And so you're intrinsically stuck with a lot of stuff in your data set. If you've got biases in your data set, your algorithm will probably be biased. Not because it's inherently biased, but just because your data was. So you've got limits with how much data you've got, what data you've got. And also, as you said, it's terrible at intuition, right? It can tell you how to reduce waste in a restaurant. It won't tell you why that's important. It won't even, it's not going to decide for itself that waste was something you should go look at. So in the end, it really is just, I mean, the way we said, it's like it's a decision optimization technology. And that's really the extent of it. It certainly isn't black magic, and it certainly won't leap you to profit all by itself.
So there isn't some kind of ritual sacrifice going on in the back room of...
No, people seem to believe that. It's like, I don't know if you find this, Erik, it's like either people massively overestimate it and go, it is black magic, and if I sacrifice the right chicken, and then cook it into a great meal, but if I sacrifice the right chicken, things will amazingly happen. And on the other hand, people go like, it's so incredibly complex, we can never get into it. And neither of those is true.
Yeah, I think I see that as well. I mean, if you read the media, you think about these things as mechanical horses. They're all doing, graceful things that I really want one of those. But in reality, it's more like a motor.
Okay.
Except Boston Dynamics, they do some really strange,
that's
scary
one
stuff.
Example, but it only took 200 years to get there.
So I'm not a data scientist, but what I wonder is how much of the and I don't know the correct term from it, but as you observe and collect all this data, are you then changing the outcome, right? So that you have to keep refining it. So in the example of pizza, right? Weather doesn't impact pizza, but if you're able to provide pizza with more people faster and better, then they're ordering it more, right? So you're sort of, it seems like, and both of you, like as you're applying it, you're actively changing what you are looking at. Is that correct? Am I wrong? Like, I'm just wondering how much do you have to keep evolving, not just based on new inputs coming in, but also just on how you're pushing the whole thing, how you're changing the system.
Yeah, I mean, absolutely. I mean, it's that sort of actuation loop I was talking about. What I'd say is you need to set up your system for fast evolution and learning much more than having the right answer first time. So, that is the problem if you can't plug back in. I mean, we've had situations where we were training on historical data and we had yet to build the system that could actually modify things in the field, but you're really not taking advantage of it. You have to modify in the field, then remeasure, retrain your models, apply them, and keep going. And so you need to set up a system that allows you to do that on a instantaneous, somewhere between instantaneous and daily basis. Otherwise, you really won't keep optimizing. You'll just optimize to a level and stop.
Yeah. All right, excellent. So what I'm wondering is, let's say, we've got a lot of people in the audience from across the food tech landscape, right? You've got startups creating small CPG, small consumer products. You've got people doing logistics. You've got people doing all manner of different things. Let's say that they're a small company right now, but they're looking to scale. Maybe they're on the verge of getting their Series A funding, right? And they really want to incorporate artificial intelligence, or at least automate some of their systems. What are the questions you would pose to them, or should they be asking before they go too far down that path? Erik, I'll start with you.
Yeah, number one, what are you trying to solve? And to the point earlier, what number are you going to use to measure your progress towards solving that? So what does perfect look like, and where are you today? So that's one. And then two, I would say, is what's the flywheel? So let's suppose you build a model, you apply it to this problem. What's the flywheel to get more data back from the application of the model that you can use to improve it? And how does the iteration cycle look? It's not a one and done thing, but it's a very iterative kind of cyclical thing. So what does that look like?
Okay.
You kind of dog ate my homework. That was a brilliant answer. I think you got it right. Know the question. It's actually a lot like, if you've ever done OKRs, it's a lot like OKRs, right? You've got to know what your objective is. You've got to know what your key results are, because you need to know what to measure. And then it's really, you've also got to have a very honest appreciation of, can you get the data and enough data to actually think you can do that? And that might be very hard to know if you've not done it before, but one of the problems is you can say, hey, I'd love to optimize this problem, but if you can't get a set of data that you believe might, in some way represent the output of that problem, you're kind of stuck. Now you can do a lot with, if you talk about the cold start problem, you can do a lot by looking at external data sources, but fundamentally, you've got to know that you have some special source data if you really want to make an impact.
This is going to show my coastal elite bias, but I mean this like in all seriousness. If you're a startup looking to get into AI, do you need to be on one of the coasts, or is the talent, the necessary data science talent and analytics talent, is that just everywhere? Like I'm honestly asking, as you are trying to go out and build these teams.
Yeah, notice one thing we didn't say in the last question is we didn't talk about having specific technology or tools.
Yeah.
Because one thing I observed, I've been doing this for a long time now, and it used to be much harder to do these things. So in addition to the application, in addition to the data, getting the data in the right format, being able to build things and deploy things was very, very hard from a tooling and technology perspective. That over time is getting easier and easier, and it's very easy. And I think I see the same thing, or I'd say the same thing about the education as well. I read papers all the time from grad students in other domains, physics, for example, know nothing about machine learning. Read a paper, take Coursera, use an off-the-shelf cloud provider tool, and suddenly they have a machine learning system that's predicting new materials that they then discover in a lab. So if a grad student can do it, I think it's increasingly accessible.
Okay.
Now, a lot of times the nuances of how it's applied, how you translate the abstract business problem into a mathematical formulation, I mean, there's a lot of skill there. So I think for that, again, the humans are going to be essential. It's not going to be solved just by technology. There is good talent everywhere. I think platforms like Kaggle, where people around the world compete to solve these problems, prove that. So talent is out there, and it's just really a matter of inspiring people to work on interesting problems and to get access to that talent.
I think that's right. I mean, I've only ever built them on sort of the East Coast, West Coast, and if you count DC as still the East Coast, then the East Coast. But as you said, I mean, one way is just set up shop near a really good university that has good machine learning, or just pick one of the big companies that you know has machine learning. There's bound to be somebody in there that wants to join a startup that's good at it. I mean, that's really how we seeded Zume. Could be that our head of data science and our head of all data might have come from Microsoft. That is possible. But to your point with tools, I mean, you've got Kubeflow, you've got some incredible tools to set up not just models, like TensorFlow and Jupyter Notebooks that do that, but you've got amazing things to set up full kind of Kubernetes clusters that spin up APIs that you can have a great system running pretty fast. And then there's also great agencies. So maybe if you're a startup and you're saying, hey, I think I've got a problem, I think I've got the data, I don't have the experience yet, you can get kickstarted with some very good machine learning, AI sort of focused agencies out there that will formulate and start building for you while you hire people.
Okay. Is there anything inherently different about creating AI and collecting data around food? Because food is a very highly personal thing, right? It involves a lot of complexity, and it ranges. It's a living, literally a living thing that has different properties from different. One apple is going to taste slightly different or behave slightly different than another apple. Is there anything or is anything that has to do with the human being inherently complicated and messy and?
I mean, maybe the breadth, right? If you think of food as a big system, you've got everything from like industrial scale logistics to, as you were talking about, like sentiment and ingredients to what people want to purchase and why they want to purchase it. Food covers, and then you get to growing and water utilization and power utilization, fertilizer. You had a great example on that. It's just so broad. I think the topic of food is almost too big. You have to say this part of food, because everything in there is kind of almost a different discipline.
Yeah, I think the other challenge is that with respect to people as consumers of food, everyone's an expert. I know exactly what I like to eat.
And they're really poorly instrumented.
Yes, they're really poorly instrumented. So I think that's another challenge. In some domains, there are very few experts, so to most people, the technology can look very good, but everyone is an expert about what they want to eat.
Okay. I want to get back to the idea of, there are companies here, large and small. If they are looking to, let's say all they've done is just make their product, right? They've gone to market, they're there, or they're an existing company that has their go-to-market all set up. If they're looking to get into AI, what is the first step they should take, or the first hire they should make, right? Because obviously this is a very specific skill set, right? And you may be great at whipping up chocolate chip cookies and packaging them together and selling them, but you want to be able to. Again, I know you have to identify the problem and kind of go from there. But for somebody who wants to get started, they could read, to your points earlier. If you read AI articles, they're going to tell you a million different things about a million different solutions. So do you have a good first step for people?
Yeah, the playbook I would recommend is, so you have your problem clearly defined, you have your success metrics clearly defined, you have clearly defined what the data is, and you have it. Next step is the data organized? Because if you go out and hire data scientists, the first thing they're going to say is, well, where's the data? How much of it do you have? They're going to go look at it, and they're going to find all the problems with it. So if you can get the sandbox kind of constructed and get the data ready, have the data organized, and then you can even on your own do simple summary statistics. What's the most popular, least popular, what things are correlated with each other, so you can begin to kind of crawl, walk, run in that order. So
a little similarly, I would. That's absolutely great. I would also say, because you said hey, get your data in one place. That's something people don't already have. So I'd say, get your engineers to set up a data pipeline to one repository.
Yeah.
We use big data. We've also used Snowflake. They're all good techs. But it's pretty easy to set up a data pipeline and then instrument everything you can about your product and get it into that one place. Now, you've got to do everything that Erik said about the problem, get your data and start working on it. But the first thing to do is get the data, and it's amazing how many people don't have the data. So as long as you can get that data, instrument as much as you can, get it flowing to one place where you can do something with it. At least if you've got it there, as you bring on a data scientist, they can start looking and say, okay, I'm going to apply a schema to this. It might not be perfect now, but at least they've got the data to do something with. And it is amazing how often people have been in market a good while, and they just have no idea about what their product's done.
Yeah. And what I would add to that is you may find that the engineers building the data pipeline just become data scientists. Because I haven't hired a single engineer in the last 2 years who does not want to become a data scientist. I don't know if that's true in your case. So you may not actually end up needing to hire anyone because the people who build the data pipeline may just end up building all the models as well.
We've definitely had people cross over, although I definitely have some senior engineers that squint at the data scientists and go, yeah, you're just really bad coders who are good at math.
Okay, so in our last bit here, as we've said, AI is sort of seeping into everything, right? Where do you wish it would be applied right now as it relates to sort of the food tech world? What are you eyeing that go like, oh, this is a really good problem for AI to solve or to tackle or however?
Well, it seems to be seeping everywhere.
Yeah, well,
I don't know that there's one big area where, I think food waste would be on that list.
Okay.
I think food waste in the distribution channel from the 30% of food waste on the farm forward, I think is an interesting area, and that may not be an AI problem, that may be more of a market problem. That's why you see like imperfect produce as an example.
Yeah, well, you also see companies like AgShift using computer vision to sort of analyze the ripeness and market viability of different foods. So it's definitely being applied there to sort of route food better so that it doesn't, if this tomato is really ripe, we'll send it 5 miles away versus 500 miles away.
Yeah, I mean the other one, which is much longer term, I think, is really just food is so long-term human health is largely diet and exercise. Mm-hmm. It's 80% diet. Every nutrition study ends up apparently getting refuted 6 months later. So we just saw those with red meat, right?
Yeah.
It's good, it's bad, it's good, it's bad.
Yeah.
Cholesterol, another example. Sugar, other example. So I think from a long-term kind of human impact, really understanding, if there was a single data set that had exactly what everyone ate and all of the long-term health outcomes together, that would be a tremendous opportunity.
I think you're right. That's an incredible thought about if you could combine medical history information with great diet information. I think you could find a lot of ways to take a huge amount of cost and waste, not just out of actually the food pipeline, but out of our use of medicines, the use of healthcare, which is, as we know, sort of biggest industry in the US. So I think that would be amazing. And if you go right to the other end, how can you apply to farming and markets so you actually produce the right amount of things at the right time to go to the right place and use it to really reduce the impact on the world that farming system's having? And I have a suspicion those two things will plug together. If you look at sort of things that are good for human health and you trace it all the way back through, I have a suspicion they can probably be produced much more efficiently than they are. And we're going to get real problems, right? We're going to get significant problems, especially on water, like plastic creation, which food is terrible for, right, because of packaging, and then water utilization. And nothing is probably a bigger threat to global security than water utilization. Like, just throw out a really depressing fact. So you're
saying I need to stop building my Marley machine?
I would say,
because
not to
I
annoy
need my
people,
fountains.
But stop growing almonds in the Central Valley, right?
Yeah.
That would be a good one. But Australia, right? They've got 10 cities that are within 12 months of 0 day, as in run out of water.
Yeah.
But they farm rice. They use so much water to farm rice that if you stop for 12 days, you could give every city another year.
Oh, wow. All right.
And that pattern gets repeated all over the world with water utilization.
Yeah. All right, well, we are out of time. I want to thank our guests. Please give them a big round of applause.
Thank you.
You guys.